Hello everyone, today we're going to be talking about the 01 knapsack problem, which is another dynamic programming approach. Now the 01 knapsack problem states that a thief wants to steal a few bags of gold, but he has a maximum capacity given, a maximum weight given that he could carry at one time while stealing. Now in this case, the maximum weight given here for this example is 5 kg. And within that 5 kg he has to find out the bags with the maximum benefit. Now there are 4 items, 2 kg, 3 kg, 4 kg, 5 kg, and these are the corresponding benefits of those items. Now while drawing the table of the dynamic of this problem, and as you all know, most dynamic programming algorithms have this kind of table sort of simulation thing going on, and we always initialize all the 0th rows to 0, 0th row and 0th columns to 0, like we did in the longest common subsequence problem. Anyway, this thing, what we have to find out is that this part of the table, the column part, will represent the weights. Now the maximum weight given is 5. That's why we wrote the rates till 0, 1, 2, 3, 4, 5, and 0 is always the initialization point. And the rows will represent the items. Now there are 4 items. That's why it goes from 0 to 4. And 0 is always representing the initial point. Anyway, let's go with the algorithm. According to the algorithm, this is the formula that's given. So this is the formula that's given. This will determine the highest benefit that the thief could get within that maximum capacity. Okay, so, and as like the longest common subsequence problem, the last cell will determine the maximum benefit that the thief would get. Okay, so let's get on with the simulation. Now the first item, now notice this iteration will go till 4, all the 4 items. Now during the first iteration, during the first item, the thief can only take the first item. So according to the simulation, you can just take the first item and put the benefits or the value or the profit of the first item. So when the weight is 1, the first item starts from when the weight is 2 kg. The first item's weight is 2 kg. So here the value will be 0 since there is no weight with 1 kg. So in the 2 kg, when it comes to 2 kg weight, that time the benefit would be 3. So we put the benefit here. And then when it comes to 3 kg, well, we didn't go to these items yet. We're still in the first item, so we have to consider the first item only. So the benefits would all be 3 because we didn't come to these weights yet. So the thief can only take one item which weighs 2 kg and which has benefit of 3. Now coming on to the second item, that time the thief can take the first and second item. So when it comes to the third item, that time the thief can take first, second, and third. And when it comes to the fourth item, it can take all the 4 bags. Okay. So when it comes to second item, when there is no such item with weight 1, so it will again be 0. And then there is an item with weight 2, so it will be 3. Now there is another item with weight 3. The second item weighs 3, so the benefit will be 7. Okay. And then according to the algorithm, if 7 was lesser than 3, then we wouldn't have put 7 here. We would just put 3 here. We would just put whichever is the maximum. Whichever is the maximum, the previous one or the one that we get after getting into that ith item. Okay, so when it comes to the fourth item, now notice here there's something different here. It won't be more visible here. It will be more visible here, the difference that we're doing. Now when we are coming to the 4th kg item, now wait, in the second item we can only go till 3 kg, 2 kg and 3 kg. So the value of the 3 kg weight is 7, right? 3 kg weight, the benefit is 7. And when we're in the 4th kg, 4 minus 3 equals to 1. So there will 1 kg still left. So what we do is 1 kg, we will go to the previous cell and we'll see if there is any benefit in the 1 kg cell. Well, there is 0. So 7 plus 0 is the benefit for 4 kg. Alright, like when we're in the ith cell, in the ith item, we always try to consider the ith item's benefit first instead of considering the previous item's benefit. So if we see that the ith item's benefit is larger than the previous item's benefit, obviously we put the maximum one here. So the benefit here would be 7, because the ith item weight is 3 kg, 1 kg is left. So we go to the previous cell and see what's the benefit for 1 kg, it's 0. So 7 plus 0 is 7. So 7 is obviously higher than 3, so we take 7. Okay, now for the fifth item, for the fifth kg item, this is in kgs. Yeah, so this is in kgs. Anyway, for the fifth kg item, we can still take only 2 and 3 kg. So when we're taking 3 kg, that time the benefit is, for the 3 plus 2 is 5, right? So when we're taking 3 kg, the benefit is 7. And when we're taking the previous cell's 2 kg, previous cell, we always try to consider the immediate previous cell, not the previous cell's cell, just previous cell immediately before this one, the one that we're working on. And the 2 kg's benefit is 3, according to the previous cell. So the total benefit is 10. So we put 10 here. Why we're considering 3 and 2 first? Because we have to consider first, we have to check if the ith item that we're checking, the weight, the benefit of the ith item's weight is greater than the previous one or not. And 3 plus 2 makes up 5. So we're taking 10 here, because first when we put 3, the 5 minus 3 is 2. So 2 units still remain. So 2 units we consider from the previous cell. So we take 3. So 7 plus 3 is 10. Okay, moving on to the third item. Maybe it will get clearer as we go on to the other items. Okay, moving on to the third item, it starts from 4 kg. So since it starts from 4 kg, the cells before that will be same. So when we reach 4 kg, the benefit is 2. Now this is a lot lower than 7. So we don't change it. We just keep it 7, because we always try to consider the maximum benefit. Okay, so when we reach the 5th kg, that time the maximum benefit was here. Again, we can't take this item, because we're in the third iteration only, the third item only. This is the third item with the third weight, with the weight for 4 kg. Now when we consider this, so that time the weight is 4 kg. For the 4 kg item, the benefit is 2. 1 kg is left. So when we go to the previous cell, the 1 kg weight benefit is 0. So it's 0. So 2 plus 0 is 2. So it's still a lot lower, so we take 10. Okay, for the fourth item now, it comes to the 5 kg part. So all the values before 5 kg will remain the same. It won't change at all. Now when we reach 5 kg, the benefit is 9. Now the benefit is 9, but we won't change it, because 9 is obviously lower than 10. So the maximum benefit still remains 10. So this is the answer of this 0-1 knapsack problem. I guess it was fairly easy. We can look at another problem if you want. Let's look at this one. Okay, here the items are, these are the items, weight and benefit. This is weight 2, 3, 4, 5, and these are the benefits 3, 4, 5, 6. Okay, now let's move on to the simulation. Firstly, we always initialize all the 0th items and the 0th columns and the 0th rows, and then to 0, and then after that we move on from the first item. Now the first item starts from 2 kg. So 1 kg, for 1 kg it will be 0, the benefit, and for 2 kg it will be 3. And then for 3 kg, since we're still in the first item, we can't go consider these items, so the benefit will still be 3, 3, 3, like before. Okay, for the second item, we can now consider 2 and 3, these two items together. Okay, so when we go to the second item, it will be 3. Okay, when we go to the second item, it will be 3. And then when we go to the third item, the benefit will be 4, because 4 is greater than 3. Okay, so when we go to the fourth item, now again we do the same thing. Fourth item, first we do is 4 minus 3. For 3 kg, the benefit is 4. So 4, and then there's still 1 unit left. 4 minus 3 is 1, so 1 unit left. And we go to see this previous, check the previous cell, it's 0. So 4 plus 0 is 4. So it will be updated to 4. And then for fifth item, for the 5th kg, it will be 3 plus, well, 3, first the weight, like for the second item, the weight is 3. So 3 kg, the benefit is 4. So 4 plus, there's still 2 kg remaining. So we go to the previous cell, check the benefit for 2. It's 3. So 3 plus 4 is 7. Okay, for the third item, we can go take all these first three items, 2 kg, 3 kg, and 4 kg. These will be the same. When you reach the fourth kg, that time it will change to 5 because 5 is greater than 4. So we update it to 5. We're always looking for the maximum here. It's a really greedy thing. I mean, the thief definitely wants a benefit, right? Okay, so for the 5th kg, it will be first what we do is for the 5th kg, first the benefit of 4 for 4 kg is 4. And then we go to the previous cell, check for 5 minus 4 is 1. 1 is still remaining. So 5 plus 0 is 5. So 5 is lesser. So we still have 7 as the benefit here. Now for the 4th item, all will be the same until we reach the 5th kg. So 5th kg, the benefit is 6. Well, 6 is lesser than 7, so it will still remain 7. So this is the answer. 7 is the maximum benefit. And so yeah, that's about it. I hope you enjoyed the video. I hope you understood everything.